So we looked at the discrete random variable, something that's countable. Now we're going to look at our continuous random variables. So discrete random variables come from counting. Continuous random variables are coming from measuring. That's old stuff, that's stuff that we've seen earlier in this course, and it's coming back to us yet again. So when we look at these continuous random variables, we're not using a discrete table like we had. We're not using a histogram like we had. We're going to be looking at a density curve. And we've seen these someplace. We've seen these with normal distributions. That bell curve is what we call a density curve. That shape encompasses all the possible probabilities. We have a continuous x-axis of values for any x that can be measured. So the area under that curve gives us the probability for any particular range of events. And if we have a background in calculus, we can do these things using calculus skills, but it's a little bit above where we're at right now. We're not going to find the area under the curve through our calculus skills, but we are going to use our tables and our calculators, the skills that we've done before. So, a couple summaries here. Probability between 0 and 1. Continuous random variable has infinitely many possible values because it's measurable, it's continuous. All continuous probability models assign probability 0 to every individual outcome. We can only find intervals of values that have probability. So we can only find the probability that something is between 0 and 2. If I ask what's the probability of being 2, we'd say that that is 0. Okay, so we're looking at women's heights. Example on page 359. You can take out the textbook and look at it if you want, but basically what this is telling us is that if we define y as the height of a randomly chosen young woman, y is a continuous random variable because we measure height, and its probability distribution is given by a normal distribution. Heights are normally distributed, where the mean is 64 and the standard deviation is 2.7. What's the probability that a randomly chosen young woman has a height between 68 and 70? Well, before we answer that, what's the probability that a randomly chosen young woman has a height of 68? We'd say it's 0 because that's a specific value. But for a range of values, that we can deal with. We draw a picture. We draw our normal curve. This n is telling us it's normally distributed. We have a mean of 64. 64 is in the middle. We have a standard deviation of 2.7. And the question is, what is this area between 68 and 70? What is that probability? That area represents the probability. Well, how do we do this? How do we find this probability? Well, we find the z-scores. Remember that? Z-scores, data value minus mean divided by standard deviation. The z-score for 68 is 1.48. That means that 68 is 1.48 standard deviations above the mean. Z-score for 70 is 2.22. We can look up those probabilities in our tables. For a strip of probability like this, we're going to take the probability that z is less than the big one minus the probability that z is less than the little one. We're going to subtract the two probabilities, big minus little. Looking these up in table A, we get 0.9868 minus 0.9306. Cool, that's how we do it by hand. Awesome, that's great. But how do we do it with our calculator? Let's go back and review that. So let me get my calculator out here. There we are. I'm going to add a calculator page. And where do we go? Do we remember? We go Menu, Statistics, Distribution, and we're going to go to Normal CDF. Remember, inverse normal is where we go when we know the percentage. Normal CDF is where we go when we know the data values and are looking for a percentage. What's our lower bound? Well, our lower bound is 68. Our upper bound is 70. Our mean, 64. And standard deviation, 2.7. And there we go, 0.56105. Now, why is this a little bit different? Well, because it got rounded, remember? And the numbers in the table that we use in Table A, those are rounded off too. The calculator is a little bit more precise with its calculations. So what does this mean? It means that there's a 5.6% chance that if we randomly choose a young woman, she will have a height between 68 and 70 inches. And that's the end of 6.1. We now have looked at how to find the mean and standard deviation for both discrete and continuous probability distributions. And we've also looked at what a probability distribution is. Now, one thing to notice, the last thing I want you to take away is almost nothing in this section was new. This is all uses for what we've done in the past. Keep that in mind as you're working through these problems.